Hi and welcome everyone. Today I want to talk to you about our journey from Spot Ocean to Carpenter, how we switched autoscalers in production without causing any downtime, some of the problems we faced and some of the preparations we had to do for all of this. Let's start with a little bit about myself. So I'm Marius. I work as a DevOps engineer at Azure. We are a fast-growing edtech company based in Hamburg, Germany. Quite a beautiful city. I can highly recommend to visit. Did some open source contributions. I worked in the past, wrote a plugin there. I maintained some Nix packages. And you will also see some smaller contributions we made along this talk. Other than that, when it comes to me, I like to go bouldering. Maybe I go even after this talk. So if someone wants to join, talk to me later. And when it comes to Azure, we are currently operating in over 150 countries. We have more than 250 EC2 instances running our backend. Sometimes it's more, sometimes it's less. The reason I will talk all about in this talk. And with this, we handle more than 5 billion API requests daily. Very high level overview of our current backend. I don't want to go into the detail of all of these things. Just one thing you may notice is that we've adopted quite a lot of open source solutions at this point already. We have Kafka, Druid, OpenObserve. But things haven't always been this way. We started out relying quite heavily on AWS managed and other proprietary solutions. Only gradually over time, we started adopting more open source and doing more things ourselves. And today I want to focus on the compute part of this whole diagram. So most of our services are written in Go, but we also have some Rust thrown in there for good measure. We recently completed our migration from ECS to EKS, and in doing so, we thought it would also be a good time to reevaluate our options for cluster autoscalers, and we decided to adopt Karpenter. But before I go into the how and why we did this, I want to give some background. I know like everyone here is already into SRE, but so I will try to keep it short. Just talk briefly about what is autoscaling anyway. When you have an application, especially a user-facing application, then you will have very different resource needs throughout the day. Like for example, if most of your users are based in Europe, then during the daytime here, you will probably have a way higher load than you will have at night. Unless you're operating some very special kind of business. But in either way, you will want your resources to automatically adjust to this incoming load and to scale up and down based on actual traffic numbers. And when it comes to autoscaling, specifically in the context of Kubernetes, then there's three things we can do. We can scale pods vertically. So we give a pod more resources, more CPU, more memory. We can scale pods horizontally. So we create more pods running the same workload. And we distribute the traffic between them. And once we've done these things enough, we will eventually need to scale the cluster itself so that we have more nodes to actually run our workloads on. And this last part is what I want to focus on today, the cluster autoscaling. So how does it actually work? When we have a new workload coming in as a pending pod, the first thing that will happen is that you have the scheduler picking it up and trying to place it on any of your existing capacity. And once it cannot, it will be deemed unschedulable. The autoscaler will kick in and will create a new node for you. If you're on any of the cloud providers, this usually happens by talking to their API and creating a new node there. Then in the next step, we can also further optimize the capacity so that in this case, as you see on the slides, we go from 3 small nodes to 1 big node and 1 small node. So in a nutshell, we always do 3 things. We monitor for pending pods, we provision new nodes, and we remove underutilized ones. For the next slide, apology if any of the Cast AI guys are in the crowd. When I did my research, these are the popular solutions for cluster autoscaling that I was aware of. There's Cluster Autoscaler, which is part of the Kubernetes project itself. There's Karpenter, which has been more recently developed by AWS. And there's Spot Ocean as a proprietary solution by NetApp. So When we made this decision many years ago, it was quite easy for us to go with Spot Ocean. Once, because they had a lot better tooling for running your backend heavily on Spot instances, which is what we are trying to do. And they also supported multiple platforms in the sense of that you could utilize Spot instances across both EKS and ECS. Now, since then, we've fully adapted EKS. We don't have to worry about the ECS part anymore. So we decided to give Carpenter a serious look as a competitor to Spot Ocean. When we look at the high-level overview of how Spot Ocean works, you have two components to it. You have the Spot instance controller, which is the part that is running on your cluster and that monitors the current state. So it is the part that actually sees all your pending pods, that notifies then the Spot Ocean server, hey, there's pending pods, we need more nodes. You then have to give this third party of Spot Ocean access to your AWS account, so they are actually able to create new nodes for you. This, of course, has some benefits in the sense that, okay, there's a component that lives outside of your infrastructure that you don't have to manage. But on the other hand, you also have to give them more access. You have to enable them to do things on your AWS account, so it also comes with some concerns. When it comes to Carpenter, on the other hand, I want to get some terminology out of the way. So when we have a new workload entering our cluster, the first thing that happens is we need to find a node pool for it. So Carpenter will go, it will look at the resource requests of this pod coming in. It will find a node pool that has an instance type that fulfills these resource requests. It will then also check the tolerations of the pod with the taints of the node pool. And if you find multiple matching node pools, then the one with the highest weight will be chosen. This node pool then has a node class assigned, which Carpenter uses to know which security group, which AMI, and which subnets this node should be assigned in. And once we have the actual node created, there will be a node claim which is in reference to the actual node, tells us if it's healthy or not. So you can basically monitor the state of your nodes through Kubernetes custom resources directly. And if we have the same overview as we had before for Spot Ocean, we see that we got rid of this third-party component completely. We have only Carpenter running inside our cluster. We removed the need for any third party. Carpenter monitors again for pending pods and will talk directly to AWS to create any new nodes once they are needed. This, of course, comes with both ups and downs. So why did we end up choosing Carpenter? For us, it was really important that it was open source. I know a lot of companies say this, but in reality, they just care about free software. We try to be a bit better than this and to actually contribute back. But of course, also for us, it was a big point that it's free instead of paying a percentage of the savings that we had to do with Spot Ocean before. I don't want to talk down on them too much though. They do a lot of great things. They give you out-of-the-box observability. They have great dashboards. They support multiple platforms in EKS and ECS. And I believe also GCP and Azure, but don't quote me on this. They have resource recommendations, and also the maintenance overhead is a lot lower once you have it running. So especially with Carpenter, we adopted at version 0.37. Then they upgraded to version 1. We had to basically rewrite all our dashboard because most of the metrics changed. That was a lot of fun. But one important thing for us was also that Carpenter is notably faster. So since we are almost exclusively running on Spot instances, it matters a great deal to us that node provisioning is happening fast. So the time from a pod is pending to a new node enters the cluster should be as low as possible. And Carpenter happens to be doing a better job at this than Spot Ocean. So with the decision being made, we decided we want to go to Carpenter. A few problems we had to solve and a few decisions we had to make. First of all, it's a little chicken egg problem since Carpenter is like managing all the nodes in our cluster, but we also need a node for Carpenter to run on. What do we do? What came first, the Carpenter or the node? Jokes aside, of course, the node has to come first. And we had the options between Fargate and a managed node group for this. For a managed node group, it's cheaper. It's just another node. It's essentially a group of EC2 nodes that we spin up ourselves, and we don't let Carpenter control these. We just manage them by ourselves. Fargate, on the other hand, is the serverless option by AWS, so you don't worry about the concept of a node at all. You just run individual pods with their resource requirements, and it's more expensive and also requires some special treatment in certain cases. But we still decided that for us, the availability of Karpenter is so important that we went with Fargate for this. Some problems that we figured out with this that weren't obvious for us in the beginning is that you have to change your security groups to actually allow traffic to flow between pods running on Fargate and pods running on your regular EC2 nodes. And also daemon sets become a little bit more tricky because Fargate nodes are not technically nodes, but they still show up as nodes from the point of view of your cluster. So all your daemon sets will still go and will try to schedule on them. So you now need to go through all of the daemon sets in your cluster and you add this node affinity to tell them, hey, if it's the compute type Fargate, then please don't even try to schedule there. It's not going to work anyway. Once we were done adding this to all of our daemon sets, we even went out of our way to add another pull request to the Prometheus node exporter to also add this by default. We saw that by nowadays, a lot of Helm charts already do this. Also the same for other versions of Azure and GCP Spot Fargate equivalents. And yeah, now transitioning time. We technically didn't have to do any of this since we didn't bring the cluster up from zero. We could have just used the existing nodes that were managed by SpotOcean to run Karpenter on them. But there's also cases where we do want to bring our cluster up from nothing. So we want to shut down our test environments at certain times. Because most of our developers are all based in a certain region, we're all based in Germany. There are certain times when no one is at work. And during these times, we don't want to pay for our test environments. SpotOcean made this super easy. You could just set a schedule for, hey, this is when the environment should be up and down. And it would even scale to 0 without any problem. Since SpotOcean has this third-party component that is running outside your cluster, they had no issues with talking to AWS in the morning, saying, hey, I need a node. The Spot instance controller will come up and the rest of your cluster comes with it. With SpotOcean, with Karpenter, now things became a little bit more tricky. We now have 2 cron jobs for scale up and scale down. And we're gonna patch all our node pools individually. So the first step is to set the CPU limit to 0. We drain all the nodes, we delete all the nodes, but with the setup, we can never really scale to 0. Another downside of adapting Karpenter. We always have Karpenter itself and also CoreDNS is a dependency running on their Fargate nodes. If you want to scale back up, we just patch the CPU limit back to what it was originally. And these are the exact commands we are using to do this. I will share the slides afterwards, so not too much need to look at it right now. But let's talk about the actual migration process. So what did we do to go in production from one to another? The first step was to add a Fargate profile, since we didn't have any Fargate nodes in our cluster before. We do the required security group modifications so that the communication between Fargate pods and our regular EC2 ones was actually possible. We then start by restarting CoreDNS so that CoreDNS would first come up on Fargate. We check everything works. We do it one pod at a time, of course, to avoid any disruptions. And we install Karpenter. We were using the Helm charts. You have to set up all the SQS queues so you get actual notifications about spot interruptions. And we set up all the IAM permissions necessary so that it can create new nodes and do all the things it needs to do. Now at this point, we have both autoscalers running. Karpenter at this point doesn't have any nodes yet. It doesn't see any pending workloads. It has nothing to do, basically. SpotOcean, on the other side, still has all the nodes and has no reason to do anything on its side either. At this point, we went on the SpotOcean configuration. We reduced the maximum number of nodes that you can set for it by 1. We do this until we see the first pods going pending. And they would be picked up then again on the Karpenter side, who now starts creating its first own node. The most important aspect for this is that you need to have all your pod disruption budgets in place, so that SpotOcean, when scaling down, does not go and disrupt any workloads at the same time that shouldn't be disrupted. And we go through this whole process We do it one by one, carefully, until eventually all of our nodes are now on the side of Karpenter. At this point, we could delete SpotOcean from our cluster. We are on Karpenter, and we are completely happy, except there are some problems we only found after we've been running Karpenter for a while, as it usually goes. The most annoying of which was that we would now have broken nodes showing up into our cluster. So there would be certain nodes that would get stuck in an unreachable state indefinitely until we manually interfered. This can happen for a variety of reasons. So you can just get unlucky and get an instance from the cloud provider that has hardware issues, or you can have your kubelet dying on the node for whatever reason. If this happens, the node is still healthy from the view of the cloud provider, but for the point of view of your cluster, it's basically useless, and it will get stuck in this unreachable state. The dangerous part of this is that you can also have pods on it stuck in a terminating state, which then do not get replaced and can cause actual downtime for your production system. So both Cluster Autoscaler as well as SpotOcean have been handling these cases already by default automatically. Only Karpenter, at least up until version 1.1, was not. Again, when we made this transition, we were on 0.37. So for us, it wasn't doing it at all. So we had to come up with our own solution for this, which is we wrote our own little custom controller, which would watch for the taint unreachable, pass a certain amount of minutes, let it be 10 minutes at this point, and then goes terminate the node. It's really not that difficult. We even offered it as a contribution to Karpenter, so you can see the pull request on the end of the slide. They never ended up going with it. They made now their own implementation, which is a little bit more tailored to cloud provider, but they're also still not configurable. If you use their solution now, you would still have to wait 30 minutes for this broken node to go away every time. So we are still running our own controller, at least for the time being. Not integrated into Karpenter, but as a standalone controller. And with this, I want to come to conclusions. So what we are seeing so far is that node provisioning has become about 5 to 10% faster since we went to Karpenter, which again, since we are fully on Spot, really matters to us since instances coming and going happens basically every minute. We also reduce cluster cost, mostly in the sense that we don't pay the percentage to SpotOcean anymore. The cost for the cluster itself, in terms of the instances, has mostly remained the same. So there has not been a big difference in terms of instances that have been provisioned by SpotOcean compared to Karpenter. And any downtime has been avoided in the process. For lessons learned, first of all, the most important part, if you're trying to do this, your PDBs are key. Make sure you have all pod disruption budgets in place before you attempt this. Of course, it should be going without saying that you need to test the migration process before doing it in production. And we found that giving Karpenter freedom has been one of the most valuable lessons for us. In the beginning, we were trying to really push it to using the right instances for each node. We had a gazillion node pools, and each application had basically a specialized node pool where we were trying to say, hey, you need this instance type to work exactly correctly. But if you just create a default node pool that has as many instance types as possible, Karpenter does a really good job at just picking the best instance at the cheapest price for you, and you get a lot better price performance out of it. Yeah, with that, here you can see our engineering blog. We recently had an article about cloud cost reduction. You can find our previous talks. You can find the pull request that I mentioned for all these talks. Marketing asked me to have the slide for at least a minute. So I guess we can already start with questions. I tried to keep this now shorter since I also started a bit later.
All right, questions?
And here you can also find me if you want to ask any questions after the fact.
Hi. Hey, one question I have, like when we initially started using Karpenter, and then I noticed this with someone else who used it too, there was a little bit of choppiness where it scaled up and down a little bit. Did you notice anything like that? And what did you do to mitigate any scenario like that?
Choppiness in what way?
Being repriced more than it should.
Did you have spot-to-spot consolidation enabled? Because this is one thing that we found that would actually cause a similar case for us.
Okay.
For now, we have it disabled just because of exactly this reason.
Okay. That's actually
So-
interesting. Okay.
So once a node is on a spot, we found that spot instances are generally already cheap enough that we don't really care much about switching from one spot instance to another, and we would just stick with it. We only want to have the switch back in case we are currently on an on-demand instance. Then we want to go back to spot as fast as possible.
But the customer that we were using, that was talking to us, they were only on demand though. And he noticed a bit of choppiness in the sense that it was the last one or two nodes always seemed to change. So maybe it's because of the aggressive auto scaling on the workloads, but Carpenter was responding to that and changing and chopping a little bit. Yeah.
Surprising to me personally, what you could do is that Carpenter always has these two strategies of provisioning. One is when underutilized, one is when empty. So if you really find that this is an issue for certain workloads, we had one where this was the case for us. So we have one workload that always takes 8 minutes to come back up and running. What we did is that we gave it a special node pool which has the policy when empty, and then Carpenter would stop being aggressive about it at all. It would be okay, it's underutilized, but so be it.
One more? Oh, two more.
Great presentation, by the way.
Thank you.
I just wanted to ask if you guys have ever looked at EKS auto modes since you're running mainly on EKS.
And it came out recently, and as far as I understand it, it's basically Carpenter managed by AWS. So Carpenter would go into the control plane and would then be managed on AWS side. We looked at it, but we stopped looking once we saw the pricing for it, to be honest. That's sadly all I can tell you.
Hey, hello. Great talk.
Hey.
My question would be, did you have to do any kind of further fine-tuning for Carpenter to be in line with SpotOcean? Or how much fine-tuning and work went in with actually setting it up other than just the deployment and migration?
As I mentioned in the talk, we found out that, okay, Carpenter works a lot better when you actually give it a lot of freedom. In the beginning, we were not doing this properly. We were really trying to restrict it in what it would be doing. So it wasn't straightforward. Definitely, we had to do a lot of configuration of figuring out which workloads actually need their exact nodes and which ones can be run on whatever and just let Carpenter decide what is best. Other than that, of course, you have to build your own dashboards. You have to work with all the metrics. There's a lot of things you lose when you make this switch. That's been my experience.
All right. Last question. One more.
Thank you. That was a really interesting talk.
Thank you.
I wonder, you mentioned about the Kubernetes autoscaler as well as an option. Was there a reason that you perhaps didn't look at that versus the other ones that you did go for?
So the main reason at the time when we first made the choice, Carpenter was not a thing, and it was just SpotOcean and cluster autoscaler. And at this time, we were still running heavily also on ECS, so it was a lot easier for us to have one solution that manages spot instances for both of them, which made SpotOcean the relatively clear winner of these two. And then when we now later came to just EKS, it already seemed to us that, okay, Carpenter was winning so much steam over cluster autoscaler. That's more worthy to look at it, and it also seemed more fit to our policy of running everything on Spot, which is why we gave it a look over cluster autoscaler. Hope that answers it. Thank you.
All right. Thank you.